Okay, so today we're going to go ahead and talk about how to use Newton's second law to solve problems involving forces. So we're going to go ahead and solve this problem on the left. So two boys push an 8-kilogram box on a rough floor. Mike pushes the box with a 15 Newton force to the right, while Carlos pushes the box with an 18 Newton force to the left. There's a 1 Newton friction force. What is the magnitude and direction of the box acceleration? So we're going to go ahead and use these steps, which we'll use for everything in this entire unit. This is the purple on the left of how to solve problems. So first we're going to do is draw a free body diagram. So try it yourself and then check back in on the video. Okay, so for my good old free body diagram, let's see, I have my box. Looks like an 8-kilogram box. We have Mike pushes 15 Newton force to the right, so I'll call that force Mike, which is 15 Newtons. Carlos is to the left, so force of Carlos, which is 18 newtons. Okay, so now let's think about what direction friction is going to be. Okay, so the box is moving to the left, so friction opposes motion. So force of friction is going to be 1 newtons. Then let's see, we have the ground pushing up on the box, so that is a normal force. And then we have gravity, which pushes down on all objects, in this case force of gravity. Or force of gravity is always mg, so 8 times acceleration due to gravity, so that is going to be 80 newtons in this case. Perfect, cool. Next thing I do is I go ahead and choose my coordinate system. So I'm going to say the up and down direction is the y direction, and side to side direction is the x direction. So again, we'll say upwards direction is positive, and we'll say for the x direction to the right is positive. Cool. So now let's go ahead and write out Newton's second law. So we want to find the magnitude and direction of the box's acceleration. Okay, so is this object accelerating in the x direction or the y direction? Well, looks like it's accelerating in the x direction. It's not moving up and down in the y. So we're going to look at the x direction. So we will set up the x direction. So I will say Fnet x is equal to all the forces in the x direction. So in the x direction, we have force of Mike, which is a positive. We have force of friction, which is a positive to the right. We have force of Carlos, which is a negative to the left. Perfect. And we know Fnet is the sum of all the forces, which those are all on the right, is also equal to MA. So we have Fnet MA. Then we have all these forces. So force of Mike is 15, plus force of friction is 1, minus force of Carlos is what, 18? So then we can plug everything in. Mass is 8. Acceleration we want to find. Let's see, right-hand side, that simplifies to -2. We do some good old math, so acceleration is -2 over 8, which is -1/4, or we could say -0.25 meters per second squared. Cool. And that checks out. Like, we know the box is accelerating to the left, and the left-hand direction we decided was the negative direction, so that acceleration makes sense. Cool. Great. So now let's go ahead and use these steps. Let's just say I wanted to find the normal force. I didn't have that on the problem, but let's go ahead and find the normal force. So let's think about it. Normal force, is that in the x or the y? That is in the y direction. So since normal force is in the y direction, I'm going to go ahead and set up Fnet y. So we have Fnet y equals the forces in the y direction. So we have Fn and Fg. And again, we're writing out the second law now in the y direction. So we have Fn is positive, that is up. Fg is going down, that is negative. So I'm going to say Fn minus Fg. Fnet we know is always mass times acceleration. Fn we want to find. Gravity is 80. Cool. And again, we're doing step number 4, plugging in variables, and then we'll do step 5, solve for what we want. Okay, so we need to solve for Fn. So we need to know the mass and acceleration. Mass is easy, that's 8. Okay, so for acceleration, I want you to think to yourself. So acceleration we found was -0.25 meters per second squared. Is that going to be the acceleration in this case? So think to yourself and then check back in. Okay, so acceleration was -0.25 meters per second squared in the x direction. So we do not use that for the y direction acceleration. What is the object doing in the y direction? In the y direction, it is not moving up and down. There is no acceleration in the y direction. So acceleration is just going to be 0. So then I have 8 times 0 equals Fn minus 80. So then I have 0 equals Fn minus 80. Fn will turn out to be 80 newtons. Oh my goodness, so fun. Okay, so in this case, Fn and Fg are balanced. It is not moving up and down, so they're equal in size but opposite in direction. Cool. Okay, so let's go ahead and solve one more problem involving Newton's second law. So again, we're going to follow exact same steps. Let's read the problem first. So a 740 kilogram elevator accelerates upward at 1.1 meters per second squared, pulled by a cable of negligible mass. Find the tension force in the cable. Okay, so first thing we do is draw a free body diagram. Again, do it yourself and then check back in. Okay, so for our free body diagram, we have this 740 kilogram elevator. We have a cable, and in that cable we know is going to be tension force. Tension is the force of stretching in a rope or cable. We know gravity acts on all things that have mass. So the gravity in this case is going to be 7,400 newtons pointing downwards. Tension force is what do I want to find? I'll put a question mark right there. So I want you to think to yourself, do we have a normal force in this case? Okay, no. Normal force is the force of the floor pushing up on an object. So if there is nothing pushing up on that object, there is going to be no normal force. Cool. So now let's go ahead and choose a coordinate system. So let's say upwards direction is the y direction, up and down vertical is the y, and upwards direction is positive. And then we'll say side to side is the x direction, horizontally is x. In this case, this problem is just taking place in the y direction, so we just have to worry about good old y direction. Cool. So now let's go ahead and write out the second law. So we are looking at the y direction. So we can say Fnet y equals our forces in the y direction. So we have Ft, oops, sorry about that. We have Ft pointing upwards, and then gravity pointing downwards. So we can go ahead and subtract gravity. Those are the only two forces, so we only have to worry about two. Fnet is always mass times acceleration. Ft we want to find. Fg is 7,400. So now we're just at number 4, just plugging in variables, and then we can solve for what we want. So the last thing it looks like I need to plug in is the mass. Is 740. Acceleration I want to find. Then we have Ft minus 7,400. Cool. So acceleration is what? 1.1 equals Ft minus 7,400. We go ahead and do some fun old math, and I get Ft to be 8,214 newtons. Awesome. Thanks for watching.